Okay, in this video, I'm going to walk through the independent t-test in Jamovi. So this is following along with the stuff in chapter 7 on the website. So we are working with a data set from LSJ data. So we're going to go open it. It's called Harpo. So to open a data set, we go to the hamburger menu option, click open, and we want to get something from the data library. And if you're out in the data library, I had you install a few extra things in the add-ons, the modules over here. One was the learning statistics with Jamovi data sets, and the other was the R data sets. And so this is the LSJ data. So we're going to click on LSJ data, and we want Harpo. We can search. There's Harpo. So we're going to click on that. So in this data set, it's hypothetical data of 33 students taking Dr. Harpo's statistics lecture. There are 2 tutors in this class, Anastasia and Bernadette, and we have the grades for all of the students, the final grades. I think it's final grades, yeah, student grades basically, and the participant ID for students. So first always is to look at the data, and I'm noticing that there is a couple errors right now. So Jamovi tries to guess the types of data that these are, and right now this isn't quite right. So ID is actually an ID variable, and it's something that we wouldn't analyze. And grade is actually not nominal, it is continuous. So we need to verify that. Always look at your data, make sure Jamovi's importing it correctly. So we can close out of that. So everything looks good. We've got a continuous DV, a dichotomous, categorical, nominal, independent variable, and we have 33 students. Good to go. Okay, so the next is to just describe the data, look at the data a little bit more in depth. And so to do this, we're going to go to Exploration Descriptives. And I'd like to look at the variables grade. So we can look at that first, and we can get a plot of the histogram. I actually like this best. Ooh, we can get the mean on there now. Awesome. So here's a plot. It looks like it's nicely normally distributed, although we don't have very much data right now. We have our mean, which is 71.55, and that's that little dot right here. And the median is right next to it. It's another good signal that the data is pretty normally distributed. We could also split our data by tutor. And so now we can see by tutor, we have a few more people in Bernadette's section than Anastasia's. The mean looks like it's a little different. Is it statistically significantly different? We're not sure yet. That's why we're going to run the independent samples t-test. And we can compare, and it looks like there's a difference in the standard deviation. Are we going to meet the assumption of homogeneity of variance? Not sure yet. Right now, it's a little iffy. But again, we have a small sample size, and that's always a little problematic. Okay, so now the next step is always to check the assumptions. What's weird about Jamovi, and we're going to do this for every single analysis, is that most of the assumption checking, there we go, is under the run the t-test or run the statistical analysis. It's not a separate check before you run the analysis. So we're actually going to go to the next step of performing the test. So we're going to go to Analyses, T-Tests, Independent Samples T-Test, because that's the one we're doing today. And again, we do that, we know we're doing that because we have 2 categorical between subjects independent variable category, right? And a single continuous DV. That type of variable combination is analyzed with an independent samples t-test. So we'll click on that. Our dependent variable is our continuous variable. Jamovi likes to tell us that by putting the little ruler there. So we're going to put grade in there. Notice how it's graying out ID because it's not something we should be analyzing. And then grouping variable is a categorical variable, meaning it's either nominal, this little Venn diagram, or ordinal, the little bars. So in our case, tutor is our independent variable, the grouping variable, so we'll put that there. We are running students t-test unless our assumptions tell us otherwise. So for now, we can ignore that. We're going to check all the assumption checks, homogeneity test, and our 2 tests for normality. I also like to check all of these for the additional statistics. And we need to check our hypothesis. And I said in here, I just wanted to see if there's differences between Anastasia and Bernadette. I don't have any a priori before the fact hypotheses of whether Anastasia or Bernadette has higher or lower student scores. So for that reason, it's a two-tailed hypothesis, and I would choose the first hypothesis, which is the default. Okay, so we get all the results. Don't look at it yet because we have to check if we met our assumptions first. So our first assumption is, did we meet the assumption of normality? So we can look at that first with our Shapiro-Wilks test. Shapiro-Wilks is not statistically significant, therefore it suggests we do meet the assumption of normality. That's one piece of evidence. The second piece of evidence is our QQ plot, which is right here. In the QQ plot, all the dots are pretty well along the line, the diagonal lines. That's another indication that we've met normality. But we also have two other ways we could look at normality, right? So we can go back to our descriptives. And let's uncheck splitting for now. And remember, we looked at the plot. So that was our third method of looking at normality. And the plot looked pretty normally distributed. So 3 checks for us that it seems we've met normality. And the last one is skew and kurtosis. So we can go to our statistics and ask for skew and kurtosis. We can also ask for Shapiro-Wilks here. For some reason, the p-value doesn't always line up. I'm not entirely sure why. That's fine. But another piece of evidence that it seems we've met the assumption. And then skew and kurtosis. Remember, we don't just look at the values themselves, but we convert them into z-scores. So we're going to run, and I always like to do on a Windows computer, Windows key R for run, and then it's calc, C-A-L-C for calculator. So we're going to run that. And so I need to divide my skew value, 0.06, divided by my skew standard error, 0.41. So our skew z-score is 0.146. That is less than our cutoff of 1.96, and therefore skew is fine. There's no skew. So then we look at the next one. Kurtosis is 0.33, divided by the standard error of kurtosis is 0.80. And our kurtosis z-score is 0.4125. Again, smaller than 1.96, therefore all of the pieces of evidence say, yes, we have met the assumption of normality. So now we can move on to testing the assumption of homogeneity of variances. So for that, we go back to our independent samples t-test and go to the homogeneity of variances test, which is Levine's test. And again, we're looking at the p-value, and p less than 0.05 suggests a violation of the assumption, but it's not less than 0.05. It's not statistically significant. Therefore, we meet the assumption that the data has homogeneity of variance, or that the variances are equal among the two groups. So if we went back, so let's go back here. We had looked at this before and split the plots by tutor, and it looked like Anastasia had a bit of a bigger variance than Bernadette. But our Levine test is saying, yeah, there might be a difference, but it's not statistically significant. So we're not going to worry about it. We've met our 2 basic assumptions of the test. The other 2 assumptions are that we have at least interval data. Got it. Our outcome variable is continuous, and that the data are independent, meaning the students in Anastasia's section of the course are different than the students in Bernadette's section of the course. That we met that assumption. We're going to assume we met that assumption, and so we can now perform the test, which we've actually already done, right? So now it's just about interpretation. So we didn't have to change which t-test we performed because we met the assumptions of normality and homogeneity of variance. If we didn't meet the assumption of normality, we would go to Mann-Whitney U. And if we didn't meet the assumption of homogeneity of variance, we would use Welch's. But I'm just going to check this to show you something, that our values are going to be pretty darn similar in terms of p-values at least, regardless of which one we choose. And that's just because students' t-test is going to be the most robust, assuming we've met the assumptions. And if we didn't, then the others will be more robust tests. So our p-values are very close. You can see we would make a different statistical conclusion based on our alpha, based on the Welch's t-test, but it's still pretty darn close. So it's fine either way, but we meet the assumptions so we can perform students' t-test. So we perform the test. Now we're interpreting the results. Again, we first look at our p-value. Is it statistically significant? In this case, our p is less than 0.05, although it's kind of close to 0.05, so I'm a little worried. And again, that Welch's t-test kind of suggests that maybe not enough data here, or that perhaps we have a type 1 error. But we're going to just stick with what we've got and say that we do have a statistically significant difference in the grades between Anastasia's and Bernadette's course. And we would write that the T is the degrees of freedom 31, which is n minus 2, 33 minus 2. Degrees of freedom equals the T score, which is 2.12, comma, P equals 0.043. Our mean difference between the two sections is 5.48. So there's about a 5.5 difference between the two sections, with a standard error of that difference 2.6. Our Cohen's d is 0.74, suggesting it's a moderately big effect. But you're looking at this and you're like, well, who has the bigger score though, right? We could go back to our descriptive statistics from the beginning, but because we asked for the descriptives and the descriptives plots, we get that information right here. So we can see that Anastasia had a higher mean and median, but the t-test tests the mean, higher mean than Bernadette, about 5.5 points higher for students in Anastasia's section than Bernadette's section. So that's it. We've interpreted the results that Anastasia had a higher group mean. Their students in Anastasia's section had a higher mean than students in Bernadette's section. It provides you a plot, and I do mention in the chapter that I do not think it's a very good plot. I would prefer seeing this plot. This is a lot more informative to me. It shows the data, it shows the distribution of the data, it shows the mean and the mean, just the little square, and the mean, oh my gosh, the mean, which is the square, and the median, which is the line. So we've got all that information, and we just see it all. So I really like these plots much more than these plots when it comes to our t-tests. So that's it. That's all of the stuff in relation to the independent samples t-test. Add your comments and questions in the video.